2017 Calculus BC FRQ number 6. All right, question A. So they give you f of 0, f prime of 0, and then they give you the derivative formula. You can find the derivative for any, like first, second, third, fourth derivative, whatever you want, for any n greater than or equal to 1. And the function has derivatives from -1 to 1, as many derivatives as you want. And they satisfy the conditions above. And the Maclaurin series for f converges to f of x. So they tell you it converges, and they give you an interval of convergence from -1 to 1 right here. You don't know about the endpoints, though, non-inclusive. And they want the first non-zero terms of the Maclaurin series for f. They want to they want you to show that. Basically, and they want the general term. They want you to build the Maclaurin series from scratch. That's what it's asking for. So you should know that the Maclaurin series is going to be f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial plus f triple prime of 0 x cubed over 3 factorial plus ... And that's going to be the nth derivative at 0 x to the n over n factorial ... So we have f of 0, we have f prime of 0, so we need the second derivative at 0. So we're going to replace n with 1 to get the second derivative. So here, that's going to be f at 1 plus 1, so n is 1. And I'm using this formula here. It's going to be -1 times f of 1 at 0. Well, what's f prime at 0? Well, we know that's 1. So -1. So that's f prime at 0. Now f double prime. Now we need f triple prime of 0. Well, that's going to be f at 2 plus 1. So here n is 2. I can zoom in and everything will be better. So that's going to be, using that same formula, -2 times f prime at, f2, sorry, the second, I can do that, just put in parentheses. The second derivative at 0, so it's going to be -2, and f2 at 0 we just got is -1. So that's going to be 2. And then we want the fourth derivative. I'll do it that way. That's going to be f at 3 plus 1. So n is 3 in this formula here at 0. And that's going to be -3. And the previous derivative at 0, which is 2, so that's -6. So I'm going to use all that information and plug it into the formula up here. So f of x will be f of 0, which we're told is 0, plus f prime at 0. We are given that as 1x. F double prime at 0, we calculate that as -1. So this will be minus 1x squared over 2 factorial. And then the third derivative, we calculated that as 2. So it's going to be 2x squared over 2, where am I going? No, 2x cubed over 3 factorial. Now, they asked for the first 4 non-zero terms. The first one was 0, so I need to find one more. Right? No, what am I doing? 1, 2 is the second derivative, which is -1. 3 is the third. Oh, I just need one. I do need one more term is the fourth derivative, but I found the fourth derivative, right? Did I? Yeah, I did find the fourth derivative. So the fourth derivative term is going to be the negative 6 x to the fourth over 4 factorial plus dot, dot, dot. Now I need my general term. Now, here's the problem. This is a little tricky. The nth derivative is right here, but it's a recursive formula. If you look at this, it's taken the previous term, so it's not explicit, so you can't plug that in right here. It's not going to work. But let's see if we can see a pattern here. So let's simplify these. It's kind of tricky. It's a tougher problem. I think a lot of people would struggle with this one. You would have just lost 1 point on this if you messed up. Honestly, if I was taking this test, I'm not sure what would have happened. Plus the 2 and a 3. The 3 factorial has a 2, so those 2's cancel. So it's x cubed over 3 minus, and then 4 factorial is 2 times 3 times 4. Well, the 2 and a 3 cancel the 6, leaving 4. A pattern emerges. Do you see it? Do you see it? So the bottom is just going to be n, and it's x to the n. But we have an alternating series. So to get it to alternate, let me do this. Negative 1 to the n. And we're going to see if that works. It might not. So if we plug in 1, it's not going to work. We're going to get negative. So I need to add 1 to this. Now when we plug in 1 to n, I get a positive x to the first and n. So that is my general term there. So that's part A. So doing the first 4 terms was worth 2 points. That was pretty easy. But finding the general term, that was a little tricky. Determine whether the Maclaurin series described in part A converges absolutely, converges conditionally, or diverges at x equals 1. Explain your reasoning. Okay, so we need to plug in 1 and test the series. So let's do that. Let me erase all of this stuff here. So absolute convergence, what does that mean? Absolute convergence means if the absolute value of your individual terms, when you take that series, converges, then it converges absolutely. But if the absolute value doesn't converge, but the alternating series does, then you have a conditional convergence. So let's plug in 1. One for x. Okay, here we go. F at 1 equals, and that's going to be negative 1 to the n plus 1 over n. Actually, I forgot my, let me fix this. Okay, it's that series. So you can see that this is an alternating series that decreases in magnitude, whose terms decrease in magnitude to 0. So this is f of 1 is an alternating series whose terms, not the whole series, but the individual terms decrease in magnitude to 0. Therefore, f of 1 converges. Whoa, yeah. Okay, I probably shouldn't say f of 1. I'll give you a reason why. I'm just going to say that series. Okay, so I'm just saying, yeah, it is an alternating series whose terms decrease in magnitude to 0. Therefore, f of 1 converges. Then I do the absolute value of this. And you can say it's a divergent harmonic series. Or you can say it's a p series with a p of 1, therefore it diverges. So we saw that the absolute value doesn't converge, but the alternating does. Therefore, this series converges conditionally. Conditional, I'm going to write that out. I should write it out, but I'm getting lazy there. All right, so that's that. We're going to go to part C. I'm getting tired. I don't want to do this anymore, but I'm going to. Write the first 4 non-zero terms and the general term for the Maclaurin series g of x. So g of x is going to be the integral of my f of x. So my f of x is right here, but it's t. So it's going to be t plus t squared. Oh, no, minus t squared over 2. Whoa, 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 whoa. Minus t squared over 2 plus t cubed over 3. How many terms? The first 4. So I need plus t to the 4th over 4. They want the general term and the general term, plus dot dot dot, plus negative 1 to the n plus 1 all over n plus dot dot dot. Oh, x to the n factorial. Is that right? No, that's not right. Wait, is that right? Yeah, I think we're good. No, there's no factorial. Yoshida. All right, now we need a dx. And we have to take the antiderivative, so t squared over 2 plus t cubed over 6 plus t to the 4th over 12 plus t to the 5th over 20 plus dot 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 plus negative 1 to the n plus 1. That's the constant, just stays. X to the n plus 1 all over n to the n plus 1 plus dot 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 from 0 to x. So g of x, we just replace all the t's with x's. X squared over 2, x cubed over 6, x to the 4th over 12, x to the 5th over 20. Oh no, my alternating signs, where did they go? Yoshida. So sad. Okay, wow. Okay, plus dot dot dot, plus negative 1, n plus 1. Oh, that's a t. X to the n plus 1 over n plus 1 plus dot dot dot. Okay, write the first 4 terms and the general term. So that should be it. Let me check to make sure I got the answer they have. It looks beautiful. It does, it does, it does. Now on to part D. I don't know why these problems aren't hard. There's just a lot of work, and it makes me tired. I'm tired. Part D. So Pn at 1/2 represents the nth degree Taylor polynomial evaluated at 1/2, where g is a function. Use the alternating series error bound to show that. So the first 4 terms, the error for the first 4 terms. Okay, so here we go. I'm just going to say this. First, we have to state that this is an alternating series. So let's see. Yeah. So the series, we have an alternating series whose terms decrease to 0. Therefore, the error is just the next term. Less than the next term. And the next term, let's see, how many terms? The first, so it's the nth, fourth degree. P to the fourth is fourth degree, not the first 4 terms. P to the fourth is fourth degree. So it's going to be the next term, which is x to the 5th over 20. And x is 1/2. And that's less than 1/500. And I'm done. You can double check because 2 to the 5th, that's, well, 20 times 2, 5 times. So 2 to the 5th, 2, 4, 8, 16, 32. 32 times 20 is 640. Bam. We are done. 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 Oh, I forgot the negative there. Okay. So that's it. I'm tired, but such is life.